Okay, so I have given you a foldable. You have folded it along the vertical line. You cut to the fold on the horizontal line. You have 3 little booklets essentially. Okay, go ahead and make it so it looks like the 3 little booklets, so they're folded over. Okay, these are your 3 sum and difference formulas. Okay, these are 3 additional identities that you do not have to memorize. These will be given to you. Okay, and this little foldable is going to help you keep them organized as far as examples. Okay, so here are the 3 formulas. We're going to do 2 examples of each. Okay, let's talk about the formulas. Okay, the sine formula. If you have 2 angles added or subtracted inside of your sine function, okay, this is how you break it up. Okay, sine of the first, cosine of the second, plus or minus sine of the second, cosine of the first. Okay, now yours looks, yours has these 2 mixed around. Okay, I probably should change it on here. Maybe I'll just go ahead and do that. All right, that way it stays in the order of U, V. Right, yours looks like that. So sine U, cosine V, plus or minus cosine U, sine V. Please notice how if it is addition, you keep addition inside the formula. If it's subtraction, you keep subtraction inside the formula. Okay? Cosine, this is what the cosine one looks like. Please, I need to draw your attention to the plus or minus sign. What happens? Have you ever seen that before? Minus plus, what? How do we even interpret that? Yes. If you have 2 angles that are added inside of your cosine, you're going to apply this formula with subtraction. If you have 2 angles that are subtracted inside cosine, you're going to apply this formula with addition. So essentially that means the sign is going to flip. Okay? And then the same thing happens in your tangent formula. Okay? Notice how in your tangent formula, if we have the plus or minus inside tangent, it stays plus or minus in the numerator, but then in the denominator, minus plus. Okay? Now, I will remind you, you will have these to use. You just need to know how to apply them. Okay? So this is what we're going to do. We're going to go ahead and go through our 6 examples, and then I would actually like to go through a proof with you as to why, which one is it that I prove? I want to show you why this cosine one is true. Okay? You are being very trustworthy in just believing me that these are true. Okay? There's actually a proof for all 6 of these. We're just going to go through one just so you can see what it looks like and what the mathematics is behind it, because you can understand the proof with your knowledge that you have right now. Okay? But I would like to go through the examples first, and then at the end of class you can just relax and watch me prove a formula. Okay? So, let's do it. If you open your sine formula, flat, we have 2 examples to do here. Pi over 12. Is pi over 12 on the inner circle? No, it is not. And I'm asking you for the exact value of sine of pi over 12, which means punching it into your calculator is not going to be helpful. I want the exact value. Okay, so we need to think of 2 angles that add or subtract to pi over 12. I'm going to give you about 30 seconds to brainstorm. You can use your neighbor if you need your neighbor to help you brainstorm. 2 angles that add or subtract to pi over 12 that we know values, like unit circle values. Brainstorm with your neighbor. All right. Maverick, do you guys have an idea?
Yeah.
Please share.
Pi over 3 minus pi over 4.
Okay, pi over 3 minus pi over 4. If we think of these in terms of common denominators, this is 4 pi over 12 minus 3 pi over 12. Does that work? Awesome. Thank you, Maverick. So, this is really the sine of pi over 3 minus pi over 4. Okay, well, until today, we would be stuck. But today we have the sine formula. Okay? Flip back. Our sine formula is sine u cosine v plus or minus cosine u sine v. So this is how we're going to apply it. Sine u cosine v plus or minus. How do we interpret that? Which sign do we need to put here? Plus or minus, plus or minus. This is subtraction, so what do we put here? Subtraction, okay? Cosine u sine v. Okay? We've applied the formula. Now all we have to do is reduce this down, okay? So I need you to help me out. Think about what these values are because I could call on you. Tiger, what is the sine of pi over 3? Times the cosine of pi over 4. Tegan. Cosine of pi over 3. Courtney. And the sine of pi over 4. Everybody. With enthusiasm. Okay. So let's just remember basic operations with numbers, operations with fractions. Okay? Radical 3 times radical 2 is radical 6 over 2 times 2 is 4 minus 1 times radical 2 over 2 times 2 is 4. You can leave it like this, I'd be perfectly happy, but we can express it as just one big fraction, radical 6 minus radical 2 all over our common denominator of 4. That is the exact value of the sine of pi over 12. Look at that. All right. Moving on. Your next example looks like this. Okay. Now, yes, we can evaluate the sine of 120 and the cosine of 60 and so on and so forth. Or we can recognize something. Does this follow the pattern of the formula that's on the front of your foldable? It does. 10 seconds, brainstorm with your neighbor. How would we rewrite this using the formula? Brainstorm, which means talk. All right, back together. Caleb, how would you interpret this?
I said it should be the sine of 60 or the sine of pi over 3.
Okay, so let's back up a little bit. How did you get to 60?
Well, because it's like in the other thing that we did, it's the first one minus the second one.
So this right here.
Yeah.
Okay, so we can interpret this as the sine of u minus v. Right? So Caleb went on to say, well, it's really just a sine of 60 degrees, which is radical 3 over 2. A lot simpler than evaluating 4 different trig functions and then subtracting them. Okay? You may also be presented with a problem that doesn't have a unit circle value. Just write this as the sine of a single angle, sine of 60. Okay. Moral of the story here, we need to be able to apply this formula both forwards and backwards. Okay? Can you apply it when there's addition or subtraction inside of the sign? Can you apply it when you have the pattern of the formula all stretched out and go backwards? All right. Go ahead and stare at that cosine formula on the front for a moment. Okay, we're just going to talk through it here. Cosine of u plus or minus v is going to be cosine u cosine v minus plus sine u sine v. Okay, so we're still going to keep the order of the u's and v's. The minus plus is something different. It flips upside down. And notice how our first two have cosine, our second two have sine. Okay, where up here we had sine and cosine mixed together. All right, so open your flap. Here is this one. We are simplifying an expression. Okay, we have addition inside of cosine. The only thing we can do is apply the sum formula. Okay, so go ahead and take a look at the front of your flap here. When we have addition inside of cosine, we have cosine theta. So cosine u, cosine v. Grace Carson, what goes here? Minus, if it's addition here, we have subtraction. Sine u sine v. Are we done? We're not done. We can't call it a day yet. Okay. Eli, what do we know about the cosine of 3 pi over 2? Ah. What do we know about the sine of 3 pi over 2? Richard, what is it? Negative 1. So we have the cosine times 0 minus sine times negative 1. The cosine of theta plus 3 pi over 2 is the same as the sine of theta. Who would have thought? Who would have thought? Okay. So far we've seen 3 types of problems. We've seen 2 problems where we're simply applying the formula forwards and backwards. Here we just simplified an expression. We were still in terms of theta. Here we get to prove an identity. Okay, some of you are like, oh, I thought we were done with that. Nope. Nope, not until after the chapter 5 test will we be done proving identities. But this might be one of the best identities we get to prove. Okay? Why do I say that? We only have one option. What is that one option that we have? The formula, right? We have subtraction inside of cosine. The only thing we can do is use the difference formula.
So if you already know what we're going to do we have to say what we're doing when we do it?
Well, you still need to tell me difference formula. Yeah. You're not getting out of those. You're not getting out of those. So let's apply the difference formula for cosine. We have the cosine of u times the cosine of v. Addition or subtraction? Do we need addition or subtraction, Callie? Addition. Sine of pi over 2 sine of x. Okay? From here, it's going to feel very similar to what we just did, right? I don't want you to go directly now to sine of x equals sine of x. I do want this step in between. I need to see you evaluate the cosine of pi over 2 and the sine of pi over 2. Okay? The cosine of pi over 2. Haley, what is the cosine of pi over 2?
Around 2/2. Oh, wait. Sorry, I'm like all messed up.
You're okay.
It's the cosine is 0.
Very good. The cosine is 0. Okay? So Haley, I'm going to have you help me with the sine of pi over 2 too.
Sine of pi over 2 is 1.
Good. Okay, all we did was evaluate those trig functions, so that can be your explanation there. Okay, I do need to see that step. I need to see you evaluate cosine of pi over 2 to be 0, sine of pi over 2 to be 1. Then from there, we know that 0 times cosine is 0, plus 1 times sine of x is sine of x. Okay, and we multiply. Okay, I will tell you that you are going to have an identity to prove on your quiz on Friday. All right, but if you can reference the formulas, it should be very helpful in your proving of your identity. All right, we're 2/3 of the way there. Let's get our other two problems here for us. Okay, go ahead and turn back and just look at the tangent formula. Okay, the tangent formula is big fraction, not scary. Okay, we have tangent u plus or minus tangent v all over 1 minus plus tangent u tangent v. Notice how the way that I wrote the formulas for you, the u and v are always going in order. Okay, so that is helpful for you. Okay, our first tangent example is to simplify. Okay, I'm going to give you about 20 seconds to just use the tangent formula to rewrite that right there. Just the one step. There's a sum inside. Go ahead and apply the formula. All right, Lindsay L., what did you write down?
I wrote tangent theta plus tangent 3 pi over 1 minus tangent theta over tangent 3 pi.
Do you agree? Yeah, okay. I see some head nods. Good. Now from here we need to evaluate. Now Caleb was feeling a little nervous about 3 pi.
I think is
Okay.
it 180?
Okay, 3 pi is in the same place as pi is what Caleb is thinking. Do you agree with that? Okay, so 1 pi, 2 pi, 3 pi is coterminal to pi. So when we're evaluating the tangent of 3 pi, we can really just think about the angle pi. All right, so think about what the tangent of 3 pi would be. We have tangent of theta plus the tangent of 3 pi. Let's see. Tegan, what's the tangent of 3 pi? Is it 0? She's unsure. Can somebody give her some reassurance? I see some head nods. Yes, tangent of 3 pi is 0. Okay. So essentially, we have tangent of theta plus 0 over 1 minus 0. Okay? If I have an angle and I add 3 pi to it, we're going to have the same tangent value. That's what that's saying. Kind of crazy, right? Alright. Get through this last example and then I can show you a proof. Alright? Tangent of 225. I need the exact, 255, excuse me. Tangent of 255. We want the exact value. Is 255 an exact value? Or a unit circle angle? So in order to find the exact value, this is just like our very first example, we need to figure out two angles that add or subtract to 255. I'll give you 10 seconds to brainstorm. All right. Nick, what are two angles that add or subtract to 255? 225 plus 30. Who had two different ones?
I have 45 and 210.
210 and 45. What else? Those are only two? Okay. Let's go 225 and 30. Okay, we're going to get to the same place no matter what. All right, so we have the tangent of 225 degrees plus 30 degrees. All right, so we need to use our sum formula in order to be able to find the exact value. So we have the tangent of u plus the tangent of v all over 1 minus tangent u tangent v. Okay. Tangent of 225. Tangent of 225. 1? Yep. Plus the tangent of 30. Square root of 3 over 3. So if tangent of 225 is 1 and tangent of 30 is radical 3 over 3, those multiply to be radical 3 over 3. Okay, that looks pretty gross, doesn't it? Is that an answer I'm going to accept? No. There are radicals and fractions in our denominator. Okay, both are not okay. So let's take care of the radical first. If there is a radical in your denominator, you got to take care of it. Now, in this case, and this is probably going to happen with every single one of these problems, okay, you're going to have to rationalize the denominator. Okay, now since we have 1 minus a radical, we're going to have to multiply by, what did you say, Caleb? The conjugate. Okay, so we're going to have to take this and multiply by the conjugate. 1 plus radical 3 over 3. Okay, So I'll just remind you, when we multiply two conjugates together, we get a squared minus b squared. So a squared minus radical 3 over 3 times radical 3 over 3 would give us 3/9, which is 1/3. Okay. When we multiply this up here, we get 1 times 1 plus 1 times radical 3 over 3 plus another 1 times radical 3 over 3, so we get 2 of them. Plus, once again, when we multiply radical 3 over 3 times radical 3 over 3, we're getting 1/3. Okay. Grab some patience. We're not quite there yet. All right, so I'm going to combine some like terms in our numerator. We have 1 plus 1/3 would be 4/3. And then 1 minus 1/3 would be 2/3. Okay? Is this still an acceptable answer? No, it is not. But the most challenging part is behind us. Okay, all we have to do is divide by that 2/3. So our numerator, we can write as 4 plus 2 radical 3 all over 3, because they have a common denominator. And remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So I can write that we're multiplying by 3/2. Okay? Well, now this gets nice, doesn't it? This gets nice. Because the 3's cancel. And both of these terms are being divided by 2. Okay? So 4 divided by 2 is 2, plus 2 radical 3 divided by 2 is radical 3. Okay. I'm going to be very upfront with you. The tangent exact value problems are going to be the ones that require the most work. This one required maybe a little bit more work because we used the tangent of 30 degrees. The tangent of 30 degrees is what? Radical 3 over 3. What's the tangent of 60? Radical 3. No fraction there, right? Okay? My best advice to you is if you can think of one, find a sum or difference that involves a 60-degree reference angle, because the tangent is oh so much nicer. Okay? Now, is it doable with our 30-degree tangent? Yeah, it is. But it's a lot smoother if you can find that 60-degree one. Okay? All right, we're not going to have time for that proof. Oh, the quiz is not tomorrow. And that's okay. But I need you to do your homework. Look at the board, people. We have a homework assignment tonight, notes and a homework assignment tomorrow, quiz on Friday. Okay? No review for the quiz, just straight into the quiz. Okay? So I need you to be ready for that. So try your homework tonight. Attempt every problem if you can. Look at those bold ones. Use your foldable. Like I said, if you want to tape your foldable in your notes, I have kids do that sometimes. So feel free. Happy Wednesday. Drive safely tomorrow.